we're going to talk about how to write our electrons around the nucleus of an atom in a little bit easier way than we did with orbital notation. Orbital notation, we had to draw the dashes and the arrows, and that gave us kind of a good picture of what was going on there. But what we're going to do today is going to kind of shorten our process a little bit. We're still going to show the structure of the electrons in the atom, but we're going to eliminate the need for drawing the dashes and the arrows. So I'm still going to go ahead and start like that, though. You don't have to write down what I'm writing in red, but I'm going to go ahead and write out the orbital notation for aluminum. Aluminum, if we look it up, is in the 3p sublevel. So if I were going to do the orbital notation, and again, you don't have to write this down, it would be 1s, 2s, 2p, 3s, and 3p. And everything before that last sublevel would be filled with electrons, an upspin and a downspin. And then I would look at that 3p sublevel and see, where is aluminum? Where is aluminum? It's in the first place. So that means that I need one electron here. Okay? And that's what we've been doing. The way that we're going to write this for electron configuration, we're still going to write the sublevels. We're still going to write 1s. But we're not going to draw a dash above it. What we're going to do is we're going to write a number that's going to tell us how many electrons are sitting there in that sublevel. So how many electrons fit in an S sublevel? 2. So we're going to write it up top, kind of like we're squaring it. It's just called a superscript, but it's looking like we're squaring the S. So then we go on to 2s. So we have 2s, and how many electrons fit in that one? 2. 2p. How many electrons fit in all three of those orbitals together? 6. And then 3s, 2. And then when you get to that very last sublevel, you just look and see, well, where is that element? It's in that first spot, so it gets 1 electron. It could be a number anywhere between 1 and 6. And if you ever forget how many can fit in each one of those, what that number will be, if you just look at your periodic table, S holds 2. 1, 2. Every single S is made up of 2 elements, so it holds 2. If it's P, 1, 2, 3, 4, 5, 6. So 2p6, 3p6, 4p6, they all hold 6. If it's D, how many is it going to hold? 10. There's 10 elements going across there in that block. And then if it's F, it's going to be 14. So you're just going to look at your table to find out those numbers if you forget what they happen to be. So we have to do one more thing. We still have to find our quantum numbers for our last electron on this element. And if we are just writing out our electron configuration here, we will have to take the step of writing out the last little sublevel here. So 3p1, we would have to go ahead and write that 3p sublevel, the orbital notation for it, and show that we have that 1 electron, because that's what we're going to find our quantum numbers for. And I'm going to go over how we find those numbers again. Okay. The first quantum number we're going to find by looking at this number. Whatever energy level that last electron is in, that's our first quantum number. And then we look and see, well, what type of sublevel is that? That's going to be a p sublevel. So remember, we assigned values. If it was S, it was 0. If it's P, it's going to be 1. And D would be 2, and F would be 3. That's for our second quantum number. So P is going to be 1. Do y'all remember how to find the third quantum number? Good. In the middle, if you have 3 positions here, the middle position is 0. To the left is -1, to the right is +1. Each blank is just like one more space on our number line. If it was a D orbital and you had 1, 2, 3, 4, 5, or D sublevel with 5 orbitals, the middle one would be 0, -1, and -2. +1, +2. It just goes one more each time. So this is back 1, so it is going to be -1. And then how do we find the last one? Okay. Right. If we're having our arrow facing up, it's +1/2. If it was facing down, it'd be -1/2. But we only have to draw the orbital notation for that last sublevel in order to find that. Okay. So let's try another one. We're not going to do the orbital notation for the whole thing for this one. We're just going to start at the very beginning. We start with hydrogen up at the top, and we write our sublevels. So the first one is 1s2, 2s2, and 2p6. Right, and the fourth row is when it starts to get funny. So we start with 4s, but then we go down a number and get 3d10. Good. So I'm just going to put 5p right now, because we should have looked up 10 before we got started, really, and saw that it ended in that 5p sublevel. So I would know when I needed to stop writing, because we don't want to keep going and have stuff we don't need. And then when we look at our periodic table, we look and see, well, how far over in 5p is that element? So when we look at 5p, 10 is the second element. So it's going to be 5p2. And then we're going to draw the orbitals for this last sublevel. How many orbitals are in a p sublevel? 3. So this is 5p right here. And I have 2 electrons. Does it look like this? No. What do I need to do instead of that? Good. Hund's rule tells us that we're going to put 1 electron in each orbital, and then if they all have 1, we can go back and put a second one in. We only need 2. It's okay that this last one is blank, but you still need to write it on the page, because when we start trying to find that third quantum number, that's going to help us identify where the middle is. So our first quantum number is going to be what? 5. And it's a p sublevel, so the next one's going to be 1. It's in the 0 position, so it's going to be 0. And it's facing up, so it's positive 1/2. What sublevel do we find radium in? 7s. So that's all the way down at the bottom of the table. So that means that we're going to have definitely 2 rows that we're going to have to write here. But you know what? We already wrote all the way through the end of the 5th row. It's just when we write 5p, what do we need to put instead of the 2? It would be 5p6 if it's completely full, and then we would keep going from there. So I would just go ahead and copy down what you have for 10. We have 1s2, 2s2, 2p6, 3s2, 3p6. And if it helps you to kind of mark them a row at a time, you can kind of go like that. Then we have 4s2, 3d10, 4p6, 5s2, 4d10, 5p6. And then we go on past what we've looked at so far. So we're at the end of the 5th row. We need to start row 6. 6s2, 4f. Remember, after 6s, whenever we look at this here, and I'll put that back here in a second. When we look at 6s over here, let me get a different color. Right there. When you get to the end of 6s, whoa, that's moving that. Okay. Then we have to jump down here. We're going to get all of 4f. And then we go back in the same place. And then we get 5d. So we'll have 6s, jump down here to get 4f, then back up to 5d. So 4f, how many fit there? 14. And then 5d, 10. Then 6p, 6. And then 7s, and that's where radium is, the 7s. Is it the first element? No, it's the second one. If I put a 1 there, what element would it be? It would be francium, but we want radium, so we put the 2. So our last sublevel we had, and if you were dividing it by rows, that would be a row there. I won't typically draw those lines there, but if that's helpful to you to kind of chunk it by row, then go ahead and do that. So this is 7s. It has 2 electrons. Earlier in the day, some people were trying to draw 2 dashes, and they had 1 electron in each. Remember, the number of orbitals for an S sublevel is just 1. There's an up and a down arrow that fit inside that 1 orbital. So it's this last one we draw that we're looking at. So our first quantum number is what? 7. It's an S sublevel, so what number goes with S? 0, which means there's only one position. And it's facing down, so -1/2. Okay. I want you to jump down to the bottom real quick. And we're going to look at finding the elements that match these configurations. So if we have 3D5, we go to our periodic table, we go to the 3D section, and we go 5 elements over. And which element would that be? Mn, manganese. So we just have to put Mn. We don't have to put the actual name. We'll just put Mn right there. So 4p3, we go and we look at 4p. Go 3 elements over, and what is that? Arsenic, As. 5F10, and you do need to look at either your periodic table or the one that's up here. If you look at the one that's on the wall, you'll notice the bottom 2 rows actually don't match exactly because there are different ways of kind of splitting it up and saying what's down there at the bottom. So that has 75 or 57, sorry, up there, and this one's starting with 57 down at the bottom. So it splits in different places. Like 71 is at the end there, while 71 is back up there in this one. So we're looking at this one to get our answer. So we go to 5F, last row here, we count 10 over, and what do we get? Californium. Okay, and then the last one, 2S1, lithium, Li. So on your assignment that you picked up on the way in today, there are 2 sections that we're going to look at right now. And before we leave, I'm going to show you the abbreviated form, which is even shorter. But you don't know how to do this part yet, the bottom chart, so hold off on that till we do that set of notes. But we are going to look at the top part here, and I'll go and work the first one with you. Oxygen, what sublevel do we find it in? 2p. And if it's helpful for you to write that there so you know where to stop, then write it down. So we start at the beginning. We have 1s, holds 2 electrons. 2s, holds 2 electrons. 2p could hold 6, but do we need all 6? We only need 4 because oxygen is the 4th element in that little group. So if you have room, you can do it in the little space there. You just need to, some way, draw this somewhere so that you can figure out what the quantum numbers are. If we have 4 electrons, we put 1 in each. Then we go back and get that 4th one, and that's the one we focus on. So the first quantum number is 2. It's a p sublevel, and we have our little helper up here at the top. If you forget, it tells us p is 1. What position is that electron in? Good, -1. And it's facing down, so it's -1/2. Okay, so you have 3 more of these to look at. Lead, you're going to need to have 2 rows written out, so leave yourself a little, be sure you write small enough that you can fit 2 rows across there on lead. Okay, now we're going to learn how to do the abbreviated electron configuration, which is going to eliminate a lot of our work that we have to do. So we're back on our notes, and we're going to look at these examples here. What we're basically going to be able to do is take a whole chunk of what we've been writing and replace it with a symbol of one of our noble gases. Where are the noble gases on the periodic table? Right, so that's going to be group number 18, or you can just put that it's the last column. That needs to quit. We're on our notes right now. So if we look at strontium, what number is strontium on the periodic table? Number 38. So what we want to do is we want to find the noble gas that's closest to number 38, but we've got to follow the Price is Right rules. And the Price is Right, you're trying to guess the number closest to it, but not just closest to, but without going over, right? That's the rule. So we have to find the noble gas that's closest to number 38, but we can't go over it. That's going to be krypton. Like number-wise. So if strontium's number 38, we can't go above number 38. Okay? Another way of thinking about it is you can't go past it on the periodic table. That's another way to think about it. So our nearest noble gas to strontium without going past it on the table or without going over the number 38 is going to be number 36, Krypton over here. So we're going to put Kr in brackets to start with. And what that is going to do is it's going to eliminate us from having to write 1s2, 2s2, 2p6, 3s2, 3p6, all the way through Krypton. And the reason why we didn't start with this is that we have to understand what's actually going on whenever we put that in brackets. We have to understand what that represents. So once we get through Krypton, Krypton's at the end of the 4th row, then we just continue on from there. Okay, what's after that 4th row? Jump down to the 5th row. What does the 5th row start with? 5s. And that's where strontium is. And it's the 2nd element. So we put a 2. We still need to do the quantum numbers. So we've got 5s with 2 electrons. So we have 5, 0, 0, -1/2. Because we're looking at this down arrow electron, which I did not draw very well. Okay, iodine. What number is iodine? 53. And we would be tempted to use xenon because it's right next to it. But xenon is passed on the table. It goes beyond number 53. So we actually have to use which one? Krypton again. You can also think about it as you need the noble gas that's in the row above it. That's another way to think about it. So we still have to start after Kr. So we go on and we start with row 5 with 5s2. What's after 5s? 4d10. And then 5p. And 5p is where iodine is. So we're not just going to put 5p6 and go on. We're going to stop with 5p. And it's the 5th one over. So we'll put 5p5. So we'll draw that 5p sublevel with 1, 2, 3, 4, 5 electrons. That's our 5th one that we drew. So we have 5, 1, 0, -1/2. Okay. Tantalum is number 73. So which noble gas is closest to number 73 without going over, without going past it on the table? Xenon. So we'll put Xc in brackets. And by putting that, we have essentially listed everything from 1s all the way through 5p. So then we jump down to the 6th row right after it and start there. So we have 6s2. What's after 6s? 4f, 14, and then 5d. And then how far over in 5d do we have tantalum? It's the 3rd one over. So then we draw our 5d sublevel. There's 5 orbitals with 1, 2, 3 electrons. Again, even though these are blank at the end, we still need to write them so we can figure out our quantum numbers. We're going to have 5, 2. This is in the middle position, so that's 0. And it's facing up, so it's a +1/2. So on your worksheet, I'll work the first one with you. We've got sulfur. Sulfur is number 16. So what noble gas is closest to 16 without going past it? Neon. So we'll put Ne in brackets. And that gets us all the way through 2p. So then we start with the 3rd row and we have 3s2. And then how far over in 3p do we find sulfur? It's the 4th one over. So we've got 4 electrons. This is the last one. I did that kind of messy, but we've got 3, 1. It's in the 1st position. The middle is 0. This one's -1. And then it's facing down, so -1/2.